Hi guys, Mrs. Venti here. Welcome to today's video. Today we're going to do exponents. We're using the Mind Action Series textbook. This is a grade 10 version and we are going to do exercise 2 on page 70. So we're working with negative exponents in this video. Question number 1 says, what do we do if we have x to the power of minus 2? Now the rule for negative exponents is that the variable or the number with the negative exponent needs to go home. Meaning that if it's got a negative exponent, it's not in the right place, it needs to go home. There are only two places it can go. It can only go to the numerator or the denominator. If you have a number like in our first question, where it's just a number without a denominator, there is always an implied denominator as being over 1. So all numbers are actually fractions over 1. So in this instance, because this x to the power of minus 2 is a numerator, when it goes home, it needs to go to the other side, meaning it becomes a denominator. So the answer to this question is going to be 1 over x squared. Notice that once it goes home, or once it goes to the other side, the minus sign falls away or it disappears. Now it is at home, it does not need to go back to the top, therefore it does not have a minus sign anymore. Let's look at question 2. Question 2 is sort of the opposite of 1. In 1, we had a numerator that was to a negative exponent. In 2, we have a denominator to a negative exponent. So if it goes home, it is going to go to the other side, meaning it becomes a numerator. So my answer here is going to be 1 over m to the power of minus 2 is equal to m to the power of 2. Again, the minus sign disappears and m becomes the numerator in the fraction. Question 3, we have m over 2 in brackets to the power of minus 3. So what we're going to do first is we are going to multiply the minus 3 into the brackets so that each one has got its exponent. So I've got m to the power of minus 3. I actually don't need the brackets any longer. And I have 2 to the power of minus 3. This then inverts. So if both sides go home, if 2 goes home, it becomes a numerator, 2 to the power of 3. And if m goes home, it becomes a denominator, m to the power of 3. Now 2 to the power of 3 is 2 times 2, which is 4, times 2 is 8. So my answer actually is 8 over m cubed. And that's my final answer. Question 4, I've got 3a to the power of minus 3. Now 3 has got a positive exponent and that exponent is 1. So my answer says that 3 stays as a numerator by itself. I've got a with a negative exponent, which means that a needs to go home. So a is going to become a denominator, a to the power of 3, and that's my final answer. Question 5, I've got 1 over 3 x to the power of minus 5 as a denominator. I am going to move this portion over here, and that's going to go home. So my answer is going to be x to the power of 5 over 3. Now this 1 here, I'm not writing it, it's just implied. So it can be 1x5 or just x5. And that is my final answer. Question 6, minus 5 over p to the power of minus 2. I have got this minus 2 at the denominator. So my denominator is going to become a numerator. My answer is going to be minus 5p squared. That's my final answer. Question 7, a to the power of minus 3 over 4. So again, my negative is on the numerator. It's going to become a denominator, which means it goes down. So my answer is going to be, the 4 stays at the denominator, a cube goes to the denominator, and on the top, because everything's gone, I have 1. Question 8, my minus sign is only on the x, so only this x is going to the denominator, which means as a numerator I have 3 over minus 2 x cubed y, and I write x before y because I write it in alphabetical order. That is my final answer. Question 9, I have minus 5a3 over 3b minus 4. My minus is in the denominator, and that's only on the b, so it's only the b that I move to the other side. So my answer here is going to be 5 over 3 cannot be simplified. Although it is an improper fraction, I'm going to leave it as is. So I'm keeping my minus in front. I have 5a cubed b4 as a numerator over 3 as a denominator. That's my final answer. Question 10. I have got an exponent outside of a bracket. So let's deal with this exponent first. I'm going to multiply it into the bracket. So I've got 2 to the power of minus 3, a to the power of minus 3 over 16, a minus 4. All right, so I've got a minus here, got a minus there, and I got a minus there. Let's deal with the first one. So I've got my fraction line. Minus 3 as an exponent on 2, I'm going to put it at the bottom. So the numerator becomes a denominator. It becomes 2 cubed. A minus 3 becomes a denominator a3. Then I move to the bottom, so I'm looking at that 16. 16 to the power of 1 stays at the bottom. And a minus 4 becomes a numerator, so it becomes a4, like that. So let's simplify. If I rewrite this a cubed as, if I rewrite 2 cubed, it becomes the number 8. So I've got 8 times 16 at the bottom, and then I have a4 on the top, a3 at the bottom. Let's do a quick calculation. So if I say 16 times 8 and multiply. So 8 times 6 is going to be 48. 8 times 5 is 40. Plus 8 is 48. So 8 carry 4. 8 times 1 is 8. Plus 4 is going to give me 12. So my answer is going to be 192. I have a fraction line, remember, and underneath on my denominator I have 128 as my denominator. Then what do I do with my a's? I've got literally a 4 as a numerator minus, because I'm dividing, 3. So it's 1 over 128, a4 minus 3, which equals to 1 over 128 a to the power of 1. And that is my final answer. Question 11. Let's work with all of our negative, let's do our exponent outside the bracket first. So what happens in my denominator is I'm going to have 5 to the power of minus 2, p to the power of minus 3 times minus 2. And in my numerator, I'm going to have 10 to the power of minus 1, p to the power of minus 2. It's definitely p. So p to the power of 3. That is my numerator and my denominator. So what are we going to do here? Let us work with our minus exponents. So that one, and that one, and that one. These two multiply out and become positive 6. So that becomes p to the power of positive 6. So I'm going to work with that exponent, and that exponent. So let's rewrite this. This becomes, I've got a fraction line. 10 to the power of minus 1 goes to the denominator. So it's 10 to the power of 1. P to the power of minus 2 goes to the denominator. That becomes p to the power of 2. P to the power of 3 stays on the top as a numerator. 5 to the power of minus 2 goes to the numerator. It becomes 5 to the power of 2. P to the power of 6 stays at the denominator. P to the power of 6. So in the end, I have got 5 times 5 is 25. p cubed as a numerator over 10 p. So this is 2 plus 6, which is then 8. P8 as a denominator. So that's not as simple as I can get. I have 25 over 10. 5 goes into both of them. So I'm going to say 5 goes into 25 5 times. 5 goes into 10 2 times. I've got 5 over 2. And then I've got P3 minus 8, which is going to be 5 over 2, P minus 5, which is actually 5 over 2P5. So that is one way of doing it. Another way of doing it, just also in the by and by, if I took these P3s, right, and I wrote them out separately, I said 1, 2, 3. And I did the same at the bottom with the 8. So I've got 1, 2, 3, and then I've got 5 left, right? So 5, 6, 7, 8. Then I can cancel them out and I can say, okay, 3 cancels out with these 3. So I've got P5 at the bottom. So technically this P5 is that P5 at the bottom. Just in the by and by. Different way of looking at it, but it gets you the same answer. Question 12. 15 AB3C minus 1 over 20 A minus 2 B2 C2. So let's do this in two different ways. Let's do the first way of doing this is we're just going to move everything, take everybody home before we simplify. Okay, so who are you taking home? We're going to take this A home and we're going to take that C home. So that means I have got 15AB3 over 20 B squared C squared. Now let's move this C to the bottom, C1 at the bottom, and this A to the top, A squared at the top. All right, so everybody's home. Now let's simplify. I'm going to say 15 and 20, common factor is going to be 5. 5 goes into 15 3 times and into 24 times. So I've got 3 over 4. Then I've got my A's. So I've got A, 1 plus 2. I've got B, 3 minus 2. And I've got C, 2. Because it is minus 2, it's at the bottom. Minus 2 minus 1. So what do I have as my answer here? I've got 3 over 4. A3, B1, C minus 3. What does that mean? It means that I've got a numerator of 3A, 3B over 4C3. That is my final answer. That is one way of doing it. I'm going to look at it in a second way of doing it. So let's go back to the original question. And in the original question, what I can do is I can simplify this and this exactly the same way. So I've got 3 over 4. And then I can just do cancelling out. So if I say, let's just do the A's. Okay, so if I'm looking at my A's, I'm going to say A to the power of 1. Then I'm going to say minus because I've got the division line there. And at the bottom, I've got minus 2. So I've got A, 1 minus minus 2. Let's look at the B's. I've got B3 minus for the division sign. And then I've got 2 at the bottom. And then let's look at our C's. I've got C minus 1 minus for the division sign. And then 2 at the bottom. So if I simplify my variables, I have got A, 1 minus 1 is 1, 1 minus minus 2 is 1 plus 2, so A3 as a numerator. And then I've got B, 3 minus 2 is 1. And C is minus 1 is minus 1 minus 2 is minus 3. And my fraction was 3 over 4. So if I rewrite that, with this becoming a denominator, I've got 3a3b over 4c3, which is the exact same answer. So what you have to be careful with here is when you are doing this, you have to separate the minus from the division sign from minuses in the question. Okay? Again, there are two ways of doing this. You have got the one on the right and the one on the left, whatever works for you. Question 13, we are going to deal with this minus 2 on the outside first. So let's multiply that in. I've got 3 to the power minus 2. A 2 times minus 2. B minus 5 times minus 2 over minus 2 to the power of minus 2. Now it's important that you realize, okay, let's do that the minus sign is also to the exponents of minus 2. Then we are going to say A minus 3 times minus 2 and B 1 times minus 2. Okay, this is one way of writing that. Another way of writing the exact same thing would be, instead of writing everything out in the green, I am going to flip the fraction and make it a positive exponent. So instead of having 3 as a numerator, I'm going to have minus 2, a minus 3, b as a numerator. As a denominator, I'm going to have 3, a squared, b minus 5 as a denominator. And I'm keeping my negative exponents here because all that I'm dealing with is this outside minus. And that outside minus disappears and it becomes squared. So two ways of doing the exact same thing. Let's move forward. So let's stick to the orange one. What are we going to do now? We are going to multiply the square sign in. So minus squared becomes plus. 2 squared is 4. A minus 3 times 2. B 1 times 2 over 3 squared is 9. A 2 times 2. B minus 5 times 2. Okay, so let's simplify. We've got 4 over 9. Okay, numerator, I've got A minus 6, B 2 over A 4, B minus 10. Now I want to simplify, right? So I am going to work with my exponents and I am going to say A minus 6, then minus for the fraction line, 4 at the bottom, and my B is going to be 2 minus for the fraction line, and then minus 10, which is at the bottom. So putting this together, I have 4 over 9. A minus 6 minus 4 gives me A minus 10. B, 2 minus minus 10 is 2 plus 10, B 12. Which means that my B12 becomes a numerator. B12 becomes a numerator. And my A10 becomes a denominator. That is my final answer. I really hope I didn't confuse you. Okay, question 14. We've got two fractions that we're multiplying with each other. So let's work this. We're going to work it left to right. First thing I want to do is I want to look at the signs. I'm going to minus there and I'm going to minus there. So I am going to say that minus times minus gives me plus. Next up, I want to look at my coefficients. I've got 6 over 3, 1 over 4. 6 and 4, I've got a common factor of 2. So 2 goes into 4 2 times, and 2 goes into 6 3 times. Looking at my coefficients again, I've got 3 over 3, 1 over 2. 3 over 3 cancel out, become 1 over 1. So my coefficients disappear, and what I have left is 1 over 2. So my coefficients are going to be 1 over 2. Now I'm going to deal with my x's. So x, I got 3. Because I'm multiplying, I'm going to add minus 5. 3 plus minus 5. And then I am dividing, so that's going to be minus 1 at the bottom over there. That's that one. And again, it's still the dividing sign. So minus, oh, there's nothing, no x's there. So I leave that one alone. Let's do the y's. I've got y minus 2. Because I'm multiplying, I'm going to add 3. And then I subtract because I'm dividing. Minus 1. And then again, minus 1. So let's simplify. I have got a half as my coefficient. 3 minus 5 plus 1, because minus and minus become plus. So 3 plus 1 is 4. 4 minus 5 is going to be minus 1. And then my y is going to be minus 2. Okay, minus and minus here becomes plus. So I've got 3 plus 1, which is 4. This is positive 4. And these two make negative 3. 4 minus 3 is positive 1. If I rewrite this as a fraction without any negative exponents, I have y as a numerator over 2x as a denominator. That is my final answer. Last question in this video. Okay, so first thing that you see is the divided sign, and I know the rule says divide becomes times, and this becomes the inverse. So this becomes minus 2y as a numerator over x y minus 1 as a denominator, and everything else stays the same. So it's times the inverse when I am dividing by a fraction. So minus 3 stays there, and I've got 2x minus 1 y 3 to the power of 2. What am I going to do next? Because I have a minus sign here, I'm going to flip my fraction again. So I am going to say x y minus 1 over minus 2y to the power of 3, and everything else stays the same. 2x minus 1 y 3 to the power of 2. So I sincerely hope that made sense. The first flip was because divide becomes times, and a over b becomes b over a. This is the rule for dividing by a fraction. The second fraction was because I had a negative exponent. Okay, so let's move on. This is the last line that we have. I'm writing it on a clean page. So what do? We're going to deal with our outside exponents, right? So 2 to the power of 2 is 4. Then I have x minus 1 times 2, y 3 times 2, multiplied by, now I've got a fraction. On the top I have x 1 times 3, y minus 1 times 3, over minus to the power of 3 is going to be minus. Minus times minus is plus, times minus is minus. 2 to the power of 3 is 8, y 1 times 3. That's what we got. Let's simplify. I've got 4 x minus 2 y 6 times x3 y minus 3 over minus 8 y3. Close the bracket there. So this one is technically over 1. So now we can simplify. I can get rid of these brackets, and what happens is I can say 4 and 8 simplify. 4 goes into 4 once, 4 goes into 8 2 times. So my coefficient is going to be minus 1 over 2. Then with my x's, I have got, let's start here, x minus 2, that's that one. Because I'm multiplying, I'm adding, plus 3, that's that one, and nothing in the denominators. Then let's do our y's. Y is going to be 6. I multiply, so I add minus 3. And then I divide, so I subtract 3. And now I simplify. I've taken care of everything. Coefficients, signs, x's, y's, everything are done. So my final answer is going to, well, before we get to the final answer, let's simplify. Minus 1 over 2, x. 3 minus 2 is 1. And then y. 6 minus 3 is 3 minus 3 is 0. Y is 0. So my final answer is going to be minus a half x. And that's my final answer. Or another way of writing it would be to say x over 2. X over 2 is also the same answer. Oh, sorry, minus x over 2. Okie dokie. So that marks the end of this video. Thank you for watching. I hope it made sense. When we're dealing with negative exponents, we always say the item with the negative exponent, whether it's a coefficient, which is a number, or a variable, which is a letter, we always say go home, and home is on the other side. So we've got a numerator and a denominator, and if it is a negative exponent as a numerator, it becomes a denominator. If it's a negative exponent as a denominator, it becomes a numerator. So always make sure everybody's home, and then you add and subtract according to the rules of exponents with like terms. Thank you for watching. Please like and subscribe. I wish you all the best, and bye-bye. See you in the next